Welcome to this video. In this video we have a numerical problem where we are going to calculate specific humidity and relative humidity of the room air. This room contains mass of dry air which is equal to 15 kg, mass of water vapor is equal to 0.17 kg. The room air is at temperature 30 degrees Celsius and the room air has a total pressure of 100 kilopascal. We are going to calculate specific humidity of the room air and relative humidity of the room air. So how do we calculate the specific humidity? So let's write what is specific humidity. Specific humidity equal to omega is equal to mass of water vapor per unit mass of dry air. What is the unit of the specific humidity? Kg of water vapor per kg of dry air. Now here, what is the mass of water vapor? Water vapor mass is 0.17 kg divided by the mass of dry air, that is 15 kg. So from this, specific humidity is equal to 0.01133 kg of water vapor per kg of dry air. So now we have calculated the specific humidity of the room air. Now let's calculate the relative humidity of the room air. So relative humidity can be written as the ratio of pressures. So it is the ratio of partial pressure of water vapor divided by the saturation pressure of the air. Both pressures are at same temperature, 30 degrees Celsius in this case. So in this relative humidity equation, P saturation is the saturation pressure at 30 degrees Celsius. So at 30 degrees Celsius, saturation pressure is 4.24 kilopascal. So this value of saturation pressure is known to us. But the PV, which is the partial pressure of water vapor, is unknown to us. So we cannot calculate the relative humidity. So first, we will have to calculate what is PV. So for that, I can write specific humidity. I can write specific humidity as omega equal to 0.622 PV divided by total pressure minus PV. So from this equation of specific humidity, the specific humidity is known to us. Total pressure of the room air is already given to us, which is 100 kilopascal. So this P value is already known to us. The only unknown in this equation is PV. So we will use this specific humidity equation and we will calculate PV from this equation. And then once we calculate this PV, we can use this PV into relative humidity equation and we can calculate the relative humidity. So as discussed, let's use this specific humidity equation to calculate PV, and from that PV we can calculate the relative humidity. So I will rearrange this equation. I will multiply this P minus PV on the left hand side and I will divide this omega on the right hand side. So I can write it as P minus PV is equal to 0.622 PV divided by omega. So I can rewrite it as P is equal to, take this PV on the right hand side, PV plus 0.622 PV divided by omega. Let's multiply omega on both sides. So I can write omega P is equal to omega PV plus 0.622 PV. Let's take PV common on right hand side. So PV is common here, and in bracket omega plus 0.622, that is equal to omega P. So from here I can write PV is equal to omega P divided by omega plus 0.622. So let's calculate what is PV here. So omega is equal to 0.01133 kg per kg dryer multiplied by P. P is the total pressure of room air, that is equal to 100 kilopascal. So that is multiplied by 100 kilopascal divided by omega, that is 0.01133 plus 0.622. If we solve this, PV is equal to 1.78 kilopascal. So we have calculated partial pressure of water vapor, which is equal to 1.78 kilopascal. Now let's calculate the relative humidity. So now relative humidity. So relative humidity is equal to the ratio of pressure, partial pressure of water vapor divided by the saturation pressure. Both pressures are at 30 degrees Celsius. So we have calculated PV, which is equal to 1.78 kilopascal. So PV is equal to 1.78 kilopascal divided by the saturation pressure at 30 degrees Celsius is equal to 4.24 kilopascal. So that is equal to 4.24 kilopascal. So from this, relative humidity is equal to 0.42 and in percentage is equal to 42%. So the room air is at 42% relative humidity.